Good evening, everyone. Good evening. Good evening. Good evening, everyone. Yeah, this is the first problem which you can expect in the GET exam. This is the first lecture of TOC expected questions. Today's class. This is the first problem. Can you go ahead? Can you go ahead? Let k greater than or equal to 2. Let L be the set of strings in 0, 1 whole star such that x belongs to L if the number of zeros in x is divisible by k and the number of ones in x is odd. The minimum number of states in the deterministic finite automata DFA that recognizes L is. Yeah, can you go ahead? What will be the answer you are thinking? Everyone can try. You may get this kind of problem in examination. You may get. Let's see how many people will give answer. Try everyone. What will be the answer of this problem? Let k greater than or equal to 2. Let L be the set of strings in 0, 1 whole star such that x belongs to L if the number of zeros in x is divisible by k and the number of ones in x is odd. The minimum number of states in the deterministic finite automata DFA that recognizes this. I think this is a combination of two problems. This problem is the combination of two problems. This problem is the combination of two problems. If you see the first problem, right, where number of zeros in x is divisible by k. I think the number of zeros in x is divisible by k means k states. Right? So I think one loop is going on. So whenever k, so 0, right? 0 zeros are accepted. Next one afterwards, k zeros loop will come. Right? I think this is everyone know. Number of zeros in x is divisible by k states. Number of ones in x is odd. Odd means divisible, not divisible by 2. Divisible by 2 also 2 states, not divisible by 2 also 2 states. Simply exchange the final to non-final, non-final to final. Divisible by 2, 0 state as the final state. Divisible by, not divisible by 2 means odd number, not divisible by 2. So I think state number 1 is the final state. So this is the combination of two problems. This is the combination of two problems. I think first problem k states, second problem is 2 states. Using I think a product machine, I think 2 into k, 2k states. The answer for this problem is 2k states. If anyone having any objection, let me know. If anyone having any objection, please let me know. It is a combination of two problems. First problem is k states, second problem is 2 states. Using product machine, I think k into 2, 2k. Because one is on zeros, one is on 1. There is no optimization also possible. Right? There is no optimization also possible. Because right, number of zeros, first machine is number of zeros, second machine is number of ones. Number of zeros divisible by k states, number of ones divisible by not divisible by 2 states. Divisible by 2 also 2 states, not divisible by 2 also 2 states. The only thing is finally becomes non-final, non-final becomes final. I think answer is 2x. 2x means 2k. 2k. So B is the answer. Anyone having any objection, let me know. You may expect this kind of questions. One, this kind of question you may expect. It's a combination of two problems. It's a combination of two problems. You may expect this. Yeah, let's move to next problem. Let's see the next one. Anyone having any objection? In the comment section you can write. I'm going to help you. In the comment section you can write. I'm going to help you. Answer for this one is going to be B. 2k. How 2k? For the first problem, k states. For second problem, 2 states. Using productimation, 2 into k. 2k states. This is, I think, everyone is absolutely fine. Let's move to next. Let's move to next. Yeah, this is the next one. Can you try this? Let's see how many people will give answer. L is equal to nk, where k greater than 0. And n is a positive integer constant. Remember, here n is constant. K is the one which is greater than 0, which is keep on changing. K is the one which is greater than 0, which is keep on changing. So, k value 1, k value 2, k value 3. But remember, n is a positive integer constant. N fixed. N is fixed. Let's see how many people will give answer. This kind of thing, maybe you can expect one more. This kind of thing, you can expect one more. Yeah. Let's see how many people will give. Everyone can try this. Everyone can try this. Let's say how many people will give answer. For this problem, what is the answer expecting? Yeah, I think if you observe clearly, if you want to give correct answer for this problem, please write minimal strings. I think first minimal string, if you observe, let us assume that n value I am taken, let us assume n value I am taken 4. If you take n value 4, k greater than 0, you can take k value 1 maybe. 4 into 1, 4. I think a power 4 first. So 4 a's first. Next one, if you take k value 2, 4 into 2. K value 2, 4 into 2, 8. I think it's a multiples of 4. It is a multiples of 4. I think, right, if you see 4, first 4 should be there. First, right, remember, epsilon is not accepted. Epsilon is not accepted. First 4 should be accepted. So what answer? First A, second A, third A, fourth A. I think 4 A is accepting 5 states required. The same loop will keep on repeat. After 4, next 8. After 8, next one. 4, 3 is 12. I think multiples of 4. I think answer is going to be 5 states. If you take n value 4, if you take n value 4, multiples of 4, I think 5 states. If you take n value 10, multiples of 10, I think 11 states. I think answer for this problem, I think everyone know. B is the answer. Abhishek, whatever you are saying, true, B is the correct answer for this. B is the correct answer for this. Let me know if any objection. Answer for this problem is second option, B. Just write the numbers one by one. First, a power 4 will be accepted. Assume n is 4. A power 4, a power 2 into 4 is 8, a power 8, a power 12, a power 4, a power 8, a power 12, a power 16, and so on. Multiples of 4. To accept 4 a's, 5 states required. To accept 4, right? To accept 4 a's, 5 states required. Right? 5 states required. So afterwards, right, to accept 4 a's, 5 states required. Next one is going to be keep on loop will be keep on repeating. You try the DFA, you are going to get the n plus 1. N value 4 means 5 states. N value 10 means 11 states. Please check. Answer is second option. I think everyone know this. Let's go to next problem. Yeah. I think this also we done. Let's go to next. Yeah, it is the next. Yeah. Try what is the answer for this. Let's see how many people will give answer for this. The minimal DFA contain how many states? The minimal DFA contain how many states? The minimal DFA contain how many states? And you can apply minimization algorithm. It is a DFA, you can apply minimization algorithm. I think if you observe clearly this diagram, A followed by anything is okay. BA followed by anything is okay. This automata accepting, this DFA accepting two kind of people. A followed by anything, BA followed by anything. A followed by anything, BA followed by anything. I think you can common on the right hand side. A followed by A plus B whole star, you can common. A followed by A plus B whole star plus BA followed by A plus B whole star. You can common right side. A followed by A plus B whole star, you can make common. So that is the one way you can draw, right? What is the actual DFA? First of all, identify what is the language. Identify what is the language first. First, identify what is the language. Language is A followed by anything or BA followed by anything. Right? Then you can construct the DFA. That is the one way. One more way is existing DFA, you can do minimization. Apply minimization algorithm. Right? I think partition algorithm, minimization algorithm, partition algorithm, you can start. What is the partition algorithm? All non-final one group, all final one group. All boys one group. Initially, you think that all final is one group, means all boys one group, all girls one group. Afterwards, depending upon their behavior, boys also will divide further. Boys group 1, boys group 2. Depending upon the behavior, girls also may divide further. Girls group G1, girls group G2, girls group G3. So keep on divide, something like that until two rounds are same. Consecutive two rounds are same. Just apply minimization algorithm, partition algorithm. One is you construct your own way. First, identify what is the language first. Oh, A followed by anything, BA followed by anything. Oh, to this one, what is the minimal DFA? You can try. That's one way. One more way is apply minimization algorithm. Apply minimization algorithm. Minimization algorithm, if you apply, all non-final one group. All final is one group. Right? I think initially two groups. If you apply one length strings, I think the two groups become three group. Non-final 3, initially one group. Now in the next round, non-final 3 people becomes two groups. If you go one more round, non-final 3 people become three groups. But final, there is no change. So if you observe clearly, there are 4 states. Abhishek, whatever you said, it is correct. Right? 4 states. You are exactly correct. Anyone having any objection? Right? Please write in the comment section. Small doubt also there. Please write in the comment section. One way. Identify language. You construct DFA by yourself. Minimal DFA. One more way. Already is given a minimal DFA. Apply minimization algorithm. Partition algorithm apply. All final one group, all non-final one group. If you keep on go further, all non-final group they will keep on divide. Final will not divide. Final, if you keep A also, same final. B also, same final. I think they don't change. I also done. So answer for this problem is, I think, 4 states. 3 non-final, it will become 3 states. All final is 1. Totally 4 states. Abhishek, exactly whatever you said, it is correct. Right? Let's move to next problem. Right. Let's move to next question. Yeah, try. This is going to be very interesting question. Let's see how many people will give. This is going to be very interesting question. Let's see how many people will give. Yeah, this is going to be very interesting question. Let's see how many people will give. Yeah, this is the problem. It's going to be very interesting. Let's check. Everyone can try. Everyone can try. Let f be a homomorphism. F of a is equal to 0. F of b is equal to 1. F of c is equal to empty. F of c is equal to empty. F of c is equal to empty. Empty symbol. So let us assume the empty symbol. Let us assume actually the empty string. Let us assume it is an empty string. I will change the problem also. Empty string. F of c is equal to empty string. You may be confused. Actually, I could have written empty string. Empty string. It's something like epsilon. F of c is equal to empty string. Try to understand everyone. F of c is equal to empty string. Something like epsilon. Something like epsilon. Let's see how many people will do. F of a is equal to 0 means f inverse of 0 is a. F of b is equal to 1 means f inverse of 1 is b. F of c is equal to epsilon means, right, f inverse of epsilon is c. So I almost given the answer. F of a 0 means f inverse of 0 is a. F of b is 1 means f inverse of 1 is b. F of c is equal to epsilon means f inverse of c is epsilon. F inverse of epsilon is c. Let's see how many people will give answer for this. Remember, it is an empty string. Remember, it is an empty string. I will also change after problem is over. I will also change in my problems. You also change. Fc is equal to empty string. You may be confused. It is a pi. It is a epsilon. It is epsilon. Can anyone give answer? It is a bit tricky. Then he's asking what is the f inverse of L? L is equal to 0 power n, 1 power n. So many zeros, so many ones. What is the f inverse of L? So L contains so many zeros, so many ones. So f inverse of L, f inverse of so many zeros, so many ones. So f inverse of 0, A, f inverse of 0, A, f inverse of 0, A. So like that A power n will become. Followed by f inverse of 1, B, f inverse of 1, B, f inverse of 1, B, because f inverse of so many zeros, so many ones. F inverse of so many zeros, so many ones. So f inverse of every 0 is A. F inverse of every 1 is B, like that. So I think answer is going to be A power n, B power n, where n is greater than 0. That is the one answer. Definitely, it cannot be B power n, A power n. It cannot be B power n, A power n. It is A power n, B power n. Now, some people are asking, what about option C, sir? Very interesting. See this one. See, everyone listen. So, zeros are there, ones are there. Before starting 0, you can keep epsilon. Epsilon dot 0 is 0. 0.1. In between, you can keep epsilon. You can keep epsilon anywhere. You can keep epsilon anywhere. So, f inverse of 0, A, f inverse of 0, A, and so on. In between zeros, epsilon may be there. F inverse of epsilon, C. F inverse of epsilon, C. So, and so on. I think, right, epsilons can be there in between A and B also. I think C also correct. Epsilons can be there. Epsilons can be there. Starting of A also, epsilons can be there. In between A's and B's also, epsilons can be there. After B's also, I think D also. It's an excellent question. A also, C also, D also. It's an excellent question. A also, C also, D also. Let me know anyone having any objection. Anyone says, sir, I have objection, please let me know. Everyone can try. Which one of the following language is F inverse of L? It's the MSQ. Remember, epsilon can be anywhere. Epsilon can be anywhere, right? So in between zeros also, epsilon can be there. In between ones also, epsilon can be there. Before zeros also, epsilon can be there. After ones also, epsilon can be there. So I think C also correct. D also correct. It's an extraordinary question. It's an extraordinary question. Anyone having any objection, let me know. Reddy sir, I have this doubt. You ask me, I will help. Hello? Hello? Let me know anyone having any objection. Sir, I have this problem. Sir, I have that problem. Everyone can try. Any doubt? Abhishek, do you have any doubt? Abhishek, do you have any doubt? Small doubt also there, let me know. Abhishek, do you have any doubt? F inverse of 0, A. Like there's so many zeros. F inverse of so many zeros. So many A's will come. F inverse of so many ones, so many B's will come. A's followed by B's, A power n, B power n. That is one way. One more thing is, in between zeros and ones, epsilon can be there. So C's can come in between also. Before starting 0, epsilon can be there. C's can be starting also. After ones are over, epsilon can be come at the end also. After ones, C also can come. So like that. So A also, C also, D also. It's one of the nice question. Right, perfect. Any doubt? Yeah, no one having doubt. Let's move to next. Yeah, try this problem. What is the answer? Try this problem. What is the answer? L1 DCFL, L2 is also DCFL, L3 CFL, L4 CFL, L5 regular. DCFL, DCFL, CFL, CFL regular. Last one is regular, remember. Last one is regular, remember. The most of the students will do this mistake. They will open the bracket. They will open the bracket right after doing the inside things. No. First to open, then do inside. Means whole complement is there. First to do complement. First to do complement, then do inside. Not inside, then complement. This is the biggest mistake what students will do. The only mistake what you can expect, what I can expect here is whole complement, union, whole complement. Some people what they will do union, they will do whole complement. So sometimes it will goes to wrong. My suggestion to everyone is first to open up, then do inside. So then what is the answer? If you do whole complement, it will goes to L3 complement. It will goes to L3 complement intersection L4 complement. Open first. Don't do afterwards open. Don't do that. First do complement, then open up. So if you do that whole complement, if you do L3 complement intersection L4 complement. Right now try this. If you try now, L3 is a CFL, L3 is CFL, CFL complement CSL. CFL complement may be CFL, may not be. CFLs are not closed under complementation. Everyone knows CFLs are not closed under intersection and complementation also. CFL complement CSL. CFL complement CSL. So CSL, CSL, intersection CSL. CSL means recursive. So A is correct. A, right? A is correct. He's asking recursive. So I think CSL means recursive is correct. Let's go to second option. Let's go to second option. L1 complement minus L5. L1 complement. L1 is what? DCFL. DCFL complement is DCFL. DCFL complement is DCFL. Right? I think L1 complement. See this one. L1 complement is L1 is DCFL. DCFL complement is DCFL. DCFL minus L5. Everyone know minus means it's not a primary operation, right? Right in the primary operation. It's the secondary operation. Because when you say minus, A minus B means A intersection B complement. A minus B means A intersection B complement. A intersection B complement. So DCFL intersection L5 complement. L5 is regular. Regular complement is regular. So DCFL intersection regular becomes DCFL. So it is the DCFL. B is correct option. B is correct option. So A correct, B correct. Right? Next one. Can you see the C? Can you see the C? He is asking which one of the following is a true statement. Let's go to C. Let's go to C. Right? So L3 is CFL. CFL reverse also CFL. CFL union L4. CFL union CFL. It is a CFL. CFL intersection regular CFL. I think C also correct. Let's go to D. Let's see the D. L3 is CFL. CFL complement is maybe CSL. L4 is CFL. CFL complement is CSL. CSL. So that is also correct. Right? So in the given problem, which one is a wrong statement? In the given problem, which one is a wrong statement? So I think last one is a wrong statement because he's saying CFL. It is actually CSL. D is wrong. A correct, B correct, C correct. D is wrong. Let me know anyone having any objection. L3 CFL. CFL complement is CSL. L4 also CFL. Complement is CSL. CSL intersection CSL. But he's saying CFL, so wrong. If you see the option C, L3 is a CFL. CFL reverse is CFL. CFL union CFL. CFL intersection regular CFL. So C correct. B, right? So L1 is a DCFL. Complement also DCFL. DCFL minus L5 means DCFL intersection L5 complement. L5 is regular. Regular complement is regular. So DCFL intersection regular becomes DCFL. So B also correct. See, the only mistake what the people will do the mistake is they will do inside, they will do complement. No, first you expand. Otherwise, sometimes you will get the wrong answer. First to open up. Whenever whole complement is there, please first open up. Then you do. Then you may not do any mistake. Right? So otherwise, some places you may get the wrong answer. So the answer for this problem is fourth option. Let's move to next. Yeah, this problem also interesting. Let's try. This problem also interesting. Let's try. Everyone try. Yeah, if you observe clearly here I think let's see this one. K greater than or equal to 0. If you see the minimal string, if you see 0, K value 0 also possible. So next one, first A power 5. Next one, right? First A power 5. K value 0 also possible. Next one, A power 7. Next one, A power 9. I think 5, 7, 9. I think multiples of 2 keep on going plus 5. So 5 also, 7 also, 9 also, 11 also, and so on. So if you observe clearly, so 5 length string, right? 5 length string. So 5 length string directly you will write. I think after 5 in the automata there is a loop. 5 length purpose, no loop is there. So minimal string for this problem is a 5 length. Minimal strings normally no loop. Further any loop is there or not verify. So further there is a loop. So minimal is going to be 5 length. Further there is a loop. From which place onwards loop guarantee? After 5. After 5 onwards loop is guarantee. In this, if you draw the automata for this problem, it is an infinite language. Infinite language in the finite automata, DFA, how you construct? Definitely finite states required. Infinite language, finite states, how it is possible? Because of loop. From which place onwards loop is guarantee? I think if you observe clearly, 5 length loop not required. After 5 loop is required. After 5 onwards loop is required. The constant guarantees loop. The constant guarantee loop after 5. After 5 actually 7. 7 onwards loop guarantee. 7 onwards loop guarantee means after 5. 7 onwards loop guarantee. 7 is not there, you can select 8. Answer for this problem is C. Answer for this problem is C. From 8 onwards loop guarantee. Actually after 5 after 5 loop guarantee. So I think answer is actually 7. 7 not there, closest one is 8. The answer for this problem is option C. Option C. That is the answer for this. Now can you go here? If L1 and L2 both are non-regular, then L1 union L2 is. Two non-regular, if you do union, it may be regular. Maybe. Never be regular? No, you cannot say that. May be regular? Yes, B is the correct answer. Must be CFL? When you say non-regular, it may be CSL also. I cannot say D. Surely regular, I cannot say. Never be regular, I cannot say. Right? There are two bad people. After becoming friends. There may be chance that they may change to good people. There are two people who are bad. After became friends, they may become good. So maybe regular is the correct answer. B is the correct answer. B is the correct answer. So this is also once again pumping lamp constant. I think similar problem I can read once. Can you see this? A power 2 plus 3k, B power 10 plus 12k. Here minimal string, if you observe in the first part, if you see the minimal string, 2 length. Next, right? First 2 length, next 5 length, next 8 length. Every time 3 is keep on adding. 2 plus 3, first 2, next one 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 11. So 2, 5 and so on. So minimal string is 2, no loop. But after 2 loop is required. So 5 also loop required. 8 also loop required, 11 also loop required. In the first part, loop is required from 5 onwards. In the second part, if you see, minimum is 10. Afterwards, multiples of 12. 10 plus, first to 10. Next one, 10 plus 12, 22. Plus 12, 22 plus 12, 36. 22 plus 12, 34. Every time 12 is keep on adding. First to 10. 10 plus 12, 22. 22 plus 12, 34. 34 plus 12, 46. It's keep on going. So in the second part, if you observe, until 10 no loop, after 10 loop is there. After 10 means most probably 22. According to second one, 22 onwards loop required. According to first one, after 2 means 5 onwards loop required. So answer is going to be, see this one. If I say 5, but in the second one, 10 also there. So combinedly, if you observe from where loop guarantee is after 10. So in the first part, right, after 2 also loop guarantee, but in the second one, after 10 only loop guarantee, combinedly loop guarantee after 10, after 10, I think the answer is D, 24. From which place onwards loop is guarantee? 24 onwards loop guarantee. Actual answer is after 10. 11 is the actual answer. 11 onwards loop guarantee. 11 onwards loop guarantee. Right? Fine. Perfect. Yeah, with the more problems, we'll see tomorrow. With the more problem, today we completed approximately 10 problems. With the more problems, we'll see tomorrow. more problems, right? We'll see tomorrow, right? Thank you. See you in the next class. Thank you.